CLO2.2. Compute the correlation coefficient R to determine the strength of linear relationships between two variables. Okay, in the last lesson, we talked about scatter plots representing data collected from an independent variable x and a dependent variable y. So here are two different scatter plots, and they each measured different things. So the first one on the left measured the hours a student did practice examples in studying for a test, and then the grades they achieved. And the second example gives a scatter plot of how many hours the students watched review videos and the grades they received. As you can see, in both cases, we have positive linear relationships, but they are different. The scatter plot on the left, the dots are much closer to the line of best fit, or this regression line that fits in between the data points. And in the right scatter plot, the dots are still moving in that same direction, but they're not as tight to the line. So the idea is, if the dots are closer to the line, this is a stronger correlation or stronger relationship. And if the dots are farther away from the line, it is weaker. And there's actually a measurement that we will learn how to measure and calculate that will give us a number that indicates, is the correlation strong, is the correlation weak? Okay, so that measurement is called the correlation coefficient, and we use the letter R to stand for the correlation coefficient. Now it is, you can see down here, a very ugly looking calculation. Fortunately for us in this class, we will not have to do that calculation by hand. We'll get to use our calculator to do the hard work for us. But what does R tell us? R tells us always, it tells us two things. It tells us how strong is the relationship, how close are the dots to the line or not close, and are the dots going up or are they going down? Okay, so it turns out we will calculate this letter R, the correlation coefficient, for an example in the next coming slides. But some things you should know about R that are always true is R is always going to be a number in between 1 and -1. You will never get an R that is 1.5, for example. It's always a number in between 1 and -1. And remember, I told you it tells you two things. It tells you the strength of the relationship, meaning how close are the dots to a straight line, and it tells you the direction of the relationship. Are the dots going up from left to right, or are the dots going down from left to right? So the direction is quite easy. If R is a positive number, then the dots are going up from left to right. It's a positive linear relationship, okay? If R turns out to be a negative number, as in this case, then the scatter plot would look like dots going down from left to right, a negative linear relationship. And it turns out the closer you get to 1 or -1, the closer you get to that maximum or minimum value of R, the closer the dots are going to be to a straight line. In fact, if R equals 1 exactly, the dots will fall on a perfect straight line going up. And if R equals -1 exactly, the dots will be in a perfect straight line going down. And it turns out the closer you get to 0, an R value that is very close to 0, the closer the dots and the scatter plot will look like no relationship at all, just all over the place and not really in the form of any pattern. So I want to do an example where we calculate R using our calculator. Remember, I showed you that very complicated formula, but for us in this course, there is a way using our calculators to calculate R. So the very first thing you're going to do is press mode 3.2. As you remember in LO1, we press mode 3.1. In LO2, we press mode 3.2. That's for these two calculators right here. If you have this calculator, the white calculator, you just press menu 6.2. Okay, you press mode 3.2, and hopefully you will see X, Y, and you'll have the frequency column. If you don't have the frequency column, it's no problem. For LO2, we don't really need it. It will just automatically fill out with ones if you don't use it. Okay, so what we'll do is we are taking this data that was given to us, the number of absences, and how does that compare to our final grades. So we're going to enter each one of those in. First, we'll enter the X's. So press mode 3.2, start entering the X's. You'll press 6 equals 2 equals 15 equals all the way down. And then use your arrow button to start the Y column. 82 equals, 86 equals, 43 equals, all the way down until all the data is entered. And then you will press AC in order to save the data. Okay, and let me just circle here. You were going to press mode 3.2 for these calculators, same mode 3.2. For this one, it's the same position menu, but then you press 6.2. Okay, so all the data hopefully is entered now. Once you press AC, then you are going to press, for the first two calculators on the left, you are going to press Shift and then 1, 5, 3, and you should get R equals. For the Casio white calculator on the right, you will press Option 3. Okay, this one, Shift 1, 5, 3, go ahead and press it, and you should get that R equals, I got negative 0.944. So remember, the correlation coefficient is always going to be a number between -1 and 1, and it tells you two things. It tells you the strength, and it tells you the direction. So in this case, since it's very close to -1, we're going to say it's a very strong, and since R is negative, it's a very strong negative linear relationship. So what that means is if I were to draw the scatter plot, I would predict dots going down and that the dots are very close to a straight line. So again, in summary, we've got R, which stands for the correlation coefficient. It's always a number between +1 and -1. It can never be bigger than 1 or smaller than -1. If it is exactly equal to 1 or exactly equal to -1, this is actually called a perfect positive linear relationship or a perfect negative linear relationship. Perfect meaning all the dots are exactly on a line. Now in reality that almost never happens because there's always some kind of variation when people are answering surveys. It usually just happens in physics, you know, like if you measured the speed of something falling from the sky, because it's a physics equation, it will be a perfect straight line. But usually we are in the case where we are somewhere in between 1 and -1. And you can tell from these scatter plots, if R is positive, the dots are going up from left to right. If R is negative, the dots are going down from left to right. And the closer we are to R being 0, the more it looks like the dots are all over the place and there really is not a pattern or a strong correlation between the X and the Y. So here's a summary of the ideas so far. When R is close to 1 or -1, that means that the dots are very, very close to a straight line. There's R close to 1. Let's do R close to -1. They will be very, very close to a straight line. That's called a very strong relationship. R close to 0 means the relationship is very weak. So they're going to be all over the place. Maybe it'll look kind of like you could make a line, but in the end, they're not very close to a straight line at all. That's when R is close to 0. And if you have the case where R is equal to +1 or -1, that means they are perfectly on a straight line. that would be r equals 1. And in this case, perfectly on a straight line, that would be when r equals -1. And that rarely happens in real surveys. Usually it just happens in physics relationships. Okay, if r is equal to 0, which also rarely happens, usually it's just somewhere close to 0, but r equal to 0 means the dots are all over the place and there is no relationship between x and y. Obviously, if r is between 0 and 1, that means r itself is positive, so it means the dots are going up. They can be close to the straight line, or they can be a little less strong. It could be a weaker relationship where the dots are a little more spread out, but either way, they're going up from left to right. And the other situation is when r is negative. They can be close to the straight line and going down. That would be a strong negative r value, close to -1. Or they can be all spread out, but still the overall pattern looks like it's going down from left to right. That would be r is a negative number, but it's closer to 0 and it's a weaker relationship. So let's look at these examples. Here's a scatter plot. They say r is 0.98, which means the dots are very close to the line. I would call this a very strong, positive, linear relationship. Okay, let's look at another one. Here, the r is not really close to -1. It's kind of in the middle between -1 and 0. So it is a negative relationship. I would not call it very strong. So I might call it moderate or weak. We don't need to worry too much about whether it's moderate or weak, but it's moderate or weak, negative, linear relationship. You can still see that the dots are going down from left to right, but they're not very close to the line. Okay, this one, if I didn't know that r was 0.19, I would just look at this scatter plot and say no relationship. That's what it looks like to me. But since you know that r is 0.19, that means you can make some kind of a line of best fit, but I would call this very, very weak, positive, linear relationship. Okay? And here we go. R is -0.87. So again, as you can even see in the picture, it's very clear. I would call this strong. The dots seem to match with the line pretty well. They're pretty close to the line. It's a strong, negative, linear relationship. Okay. One more, r equals 0. This is the classic. No relationship at all. You can't really put these dots to any kind of pattern. All right, so let's do some review of all that we've learned. First would be just matching the correct r value with the most probable scatter plot. Now let's start with the absolute easiest. To me, I look at dots going in a perfect straight line down, and I think this is definitely r equals to -1. The dots are going down, and they fit a perfect straight line. Okay, let's look at the other negative values. We've got r is -0.7 and r is -0.4. So -0.7 would mean they're tighter to the line than the one that is -0.4. So to me, this one looks pretty tight to a negative line, so I would put this at r equals -0.7. And let's see, maybe this one also still looks like it's going down. They're just not as tight to the line, so I would put this one at r equals -0.4. All right, the top ones, I guess the best looking one, the one that looks the most positive and tight to a line, would be this one. So that should be the biggest positive value. Let's call that r equals 0.8. And then these two, neither look very good, but let's say this one looks a little bit better. And so that would be R equals 0.3. They're not very tight to a line, but I can kind of see an upward trend. And this last one, I really don't see any pattern at all. I would put this one at R equals to 0. Okay, let's move to another example. And let's use our calculator. Let's see if we are good at finding the equation of the line of best fit. So we have measurements about production, I guess these are production quantities, and then manufacturing expenses. So usually the independent variable is the quantity you decide to produce, and that will have an effect on your manufacturing expenses. So the first step always is to press mode 3-2. If you have the other calculator, the white calculator, press menu 6-2, and then you should see the table of values X, Y. You might see the third column frequency. You can just let those fill in ones. Naturally, we don't really need them in CLO2, but we will. Why don't you pause this video, and after you press mode 3-2 or menu 6-2, type in the X's, type in the Y's, and then press AC. Okay, so after you do that, then we will try to find R. You can press Shift 153. If you have the white calculator, you'll press Option 3, and you should get that R equals 0.782. Now remember, that tells us two things. It will tell us the strength of the relationship and the direction of the relationship. So it is not that close to 1. I would call this moderate to strong. Moderate to strong. But it is definitely a positive linear relationship. So what does that mean? It means if I were to draw this as a scatter plot, I would predict that the dots are clearly going up from left to right, and they are pretty close to the line. Something like that. Not super close, but pretty close to a straight line. Okay, let's do another example. Here's another one. So let's see how good we are at learning the steps on our calculator. We've got temperatures related to sales. So maybe it's some sort of a business where the temperature does in fact affect sales. Maybe you're selling hats and gloves and mittens. And so the temperature will affect how many people want those things. So the temperature is the independent variable, and that will have an effect on the sales. So we'll press mode 3-2 on our calculator. We'll see this table of X and Y. Sometimes you might have the frequency. Just let that fill out itself. And put in each of these numbers, and when you're done, we will press AC. Okay, you can pause this video, enter that data in. When you're done, we will press Shift 153, and we should get that R equals negative 0.97794. Wow, so 0.978, I'll say, rounding it to 3 decimal places. Remember, this tells us two things. It tells us about the strength, and it tells us about the direction. Now, R is very close to -1, so I would call that a very strong, and it's a negative number, so it's a very strong negative linear relationship. So what does that mean in terms of the scatter plot? It means I expect that the dots are going down, and they are so very close to a straight line. Okay, this last slide is really a summary of a lot of the concepts from this whole video. So hopefully we can get them right. It says only 4 of these many sentences below are true. So we'll go through them one by one and see which ones are true and which ones are not. So if R is equal to -1 or 1, then all the points on the scatter diagram are a straight line. That is true. That's called a perfect linear correlation, and that is when they are all in a straight line going up or all in a straight line going down. A value of r close to 0 indicates that there is very little relationship. That is also true. R values are always positive. This is not true. As you remember, r can be in between 1 or negative 1. They can be positive or negative or 0. If r is in between 0 and 1, there's a negative correlation. Also not true. That would be a positive correlation. If r is negative 1, then there is no relationship. That is not true either. In fact, that's a perfect negative linear relationship where the dots are in a straight line going down. R can take values between negative 1 and 1. That is true. A value of r close to negative 1 indicates there is a very weak. That's not true. In fact, it's so strong. The dots will be very close to the line and going down. If r is equal to negative 1 or 1, then there's a perfect correlation. Yes, that is what it's called when they are equal to 1 or equal to negative 1. If r is between negative 1 and 0, there is no correlation. That's not true. In fact, there's a negative correlation. R squared, we'll talk more about this in a future video, but if you square a negative number, like r can be negative, if you square it, it will only be positive. So it's not true that if you square r, that it could be negative. It's only going to be positive, but we'll talk more about that in a future video. So you can see the 4 true statements and the rest are not true.